me programming when you look at the video today. I forgot to share my screen. I need to share my screen now. All right, so first thing we need to do is open up the Scratchpad project. You're welcome. Getting that stuck in your head for you. What's up?
Just looking to see what the object is. To return either 5-1 or 7.
Yeah.
It's way too short to be right.
No, mine's 2 lines long.
Okay.
Well, it's 1 line long and then the return statement. So
Okay.
are you finished? Did you finish it?
Wait,
Wait. Okay.
it's coming.
All right.
Can you write generics to handle primitive types?
No.
So you have like 6 versions, one for generics and then one for primitive type.
You talking about with regards to what?
Like if you wanted to handle anything shorthand as input.
And you were using generics? Yeah.
Seems dumb.
It is dumb. Most people, if you're using generics, don't consider primitives as like, they don't really support them essentially. So you don't need to necessarily worry about supporting those primitive types. Basically, the classes are like for newer code, and the primitive types are like, if you don't really need any of the frills in the newer code, then here's some primitive types.
Can you show us
Show you what?
what you have?
Yeah, well, we're going to give it a couple more minutes so everyone finish up, and then we'll do that. Seems like maybe you got it, huh, Lindsay?
No.
No?
I thought I got it, but I don't think I did because it's not working. Like it's not running through.
What's it doing?
It's giving me a bunch of errors.
That's a pretty good sign that it's not working.
Illegal start of expression. That's how it always happens.
It seems like maybe that's a syntax error.
I know, but it's not. Like it is, but I don't know what it is.
You're wrong, computer.
I don't know what it is.
I'm right.
I'm sorry,
Oh, you
compiler.
know what? I think I do know what it is. Hold on.
Okay.
I do.
When you're calling gimme, you give an int array as the parameter.
You get, you can just, you can make an array beforehand and pass it in, or you can, you can say new int array 517.
In the gimme.
Yeah, you can do it in the code, yeah.
What do you hit again to get the util?
What
It's not
util?
working for me.
What do you mean by the util?
Like if I want to get util, java.util array list.
Oh, so if you type in array list in your code, you hit Alt Enter, it'll import the Java util pack. Yeah, there you go.
I thought it was Alt-N and it kept hitting it.
Oh no, Command N is our code generation utility. Like you can do constructors and get this sort of stuff.
Right now.
An array list initializer is that curly bracket syntax for arrays. Where did you see the phrase array initializer? Okay.
Number format exception for
I'm not. I'd have to see it, man. Are there any decimals in the numbers that you're putting into your int array?
No, I put them 157. 1, 5.
And surrounding that is curly brackets.
Mm-hmm.
And before the curly brackets is a left square bracket and a right square bracket.
Yeah, it says new int, and then square, and then other brackets, and then active state.
Okay.
I just call that's my call.
Yeah.
In my main.
Okay. And then inside your method definition, it's like public static int gimme int brackets numbers.
Mm-hmm.
And then when you run it, it's saying what again?
It says exception number format exception for input string pointing to blah, 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 blah.
Are you calling math.random?
Yeah.
Are you trying to print that at some point?
Well, I'm not calling that and changing it to a string and then taking that integer value of
Okay,
Oh, wow.
I'm so happy that you went through that, Will. Oh, it's just a good reason why we need rubber ducks in here. That may seem very random, and I'll explain it to you later today, after I go to the store to get some stuff, rubber ducks.
Yeah, if I could explain this.
Jennifer, did you get it?
I probably would.
All right,
Cut off those.
I thought I was too. I thought I got it.
you thought you were close. Okay, well, since you can't really share your screen very well, let's have Will share his screen, so we can kind of go through what he did, and hopefully that'll help you figure out what you did, right? Okay. Okay, I'm gonna try and look at the screen here. It's not gonna be perfect. We'll do what we can. All right. So we have a public class main. Inside main, we have void, public static void main. Gimme new int 157. This is exactly what it needs to be.
Really?
Yes. Perfect. Love this part. This part. Public static int.
Wait.
Oh,
Sorry.
gimme what?
Why is that 1%? Yeah, and why does that need to be there?
Because we gotta call the method to see if it returns anything.
But isn't public static int, gimme int numbers, isn't that the method?
This is the method we're running. This is the method we're defining. We're defining the method here. We're using it here.
It's
Oh.
run its directions on the bottom and run that on the top.
It's like, hey, here's what this gimme method is named. Here's what it returns. Here's what it accepts. And up here, it's like, let's run some things starting from this line here. On this line, we put gimme new int that. Cool? Not cool. You're nodding, but your face says not cool at all. Okay, so if we take away main for a second, we just had gimme, right? What would lines 10 through 14, what would you expect them to do?
Well, I thought what I did, which is totally wrong, I guess. I did like just public static int gimme, int numbers, and then
Yeah.
I did a for loop, and I did print out for loop, and then I did gimme new int 517. So then I created a new array, right?
Okay.
And that's what I thought I was doing.
Well, what would the new array be telling you? Like what data would it hold?
I thought that would be calling that method because it's called gimme, right? So I thought it would be calling it and passing in those numbers.
But you put that inside of gimme?
No, I put it outside gimme.
You put it in main?
Yeah.
Okay. So let me rethink about that. So you have inside main, you have a for loop. Inside the for loop, you're making a new array.
Mm-hmm. I mean, like I'm iterating over the array that's passed through it.
Okay, so in main you defining a new array, an int array, and then inside the for loop for each element in that array, you are calling gimme on the array.
Yeah.
So what that's going to give you is 3 random numbers. It's going to print out 3 random numbers. They're not going to have any relationship to one another.
Aren't they in the same array though? Like I thought I was calling it on like the array that I'm passing through.
You are like, okay, so the job of, well, what are you doing, man? I'm trying to figure out. All right, just hold on a sec. Okay, so what we want to do is, given an array, we want to return an int. Okay, that's what gimme is. It's a method that has an array. It takes an array here, returns an int. And we'll check out line 10. The method signature here is a little bit off. Public static int gimme int numbers. We want to accept an array of integers as our numbers, and we want to return 1 integer. So you
Oh.
would, yeah. Okay, so this part's correct. I mean, it's probably the same as what you had, Lindsay.
Mhm.
So you have public static int. So gimme is a method, accepts an array of integers, returns one of them. Which one? We need to implement that in our method,
I
right?
think I misunderstood the concept of it.
Okay, cool.
Sorry, real quick, what were you about to say?
No, go ahead.
What makes line 10 an array? Or line 7 an array?
Okay,
I thought I actually had have the words array.
you do not, array is not a word that you have to type in to make an array. These brackets here they indicate an array type. So like, you see, this is how you specify that your parameter is going to be an array. Or if you want to make a variable that is an int array, you would say like int brackets numbers equals new array. No, it's not new array, it's new int. And then square brackets and a number. I'll go over another example. There's also in the notes for one of last week's lessons, that syntax is like right there. And also probably in that website I sent you last night, that I think it goes over array declarations. So yeah, gimme is a method. Its job is to input an integer array of numbers and then give us one of those numbers. Okay, and we know from the assignment that its job is to give us one random number from the array, right? So that's what we have to implement here. When we're here in main, when we call gimme, we're expecting to either see a 1, a 5, or a 7. And we can't say which one, just arbitrarily is supposed to give us one of them, right?
Mhm.
So,
And that's what we call math random.
indeed. All right. Now, Will, talk to us about your approach here. So you have math.random. That's a good step. It's encouraging to see that. So we're trying to convert that to a string.
Mm-hmm.
What would a string give you that a double didn't give you? Why would you want to make that conversion?
That's the only way I know how to get computer from a double.
Okay. Let me blow your mind for a sec. Take away double.to string. The whole thing, the double part as well. Okay, stop there. Do you remember when we talked about casting?
Fantastic.
Okay. Open parenthesis. Type that. There. Yeah. Open parenthesis, int. Close parenthesis. And then change this type to an int.
Does that always be 0?
Can you do that?
Sorry?
That always be 0.
Yes. I'm not finished this yet. So math.random is going to return a number between 0.00 and 0.99. What we wanted to have it return is a number that is the maximum size of the array, right? So we want to get an integer that represents an index, right? Now, one trick that you can do for that is to multiply math.random times the length of your array. So go ahead and inside these parentheses after the math.random, type times, or the asterisk, I mean, outside of the call to random, yeah, right there, times numbers.length. So this is a pretty common trick to get a random number at most a certain maximum. If you think about what's going on here, it kind of makes sense, right? So the valid numbers for an array of length 3, the valid indices are 0, 1, and 2, okay? So if you think about it logically, an array with 3 elements has 3 valid indices, 0, 1, and 2, right? So if math.random returns 0.00, its lowest possible value, and you multiply that times 3, you're going to get an index of 0, right? If math.random returns like 0.4, 0.4 times 3 is greater than 1 at least, so it's going to return a double that is like one dot something. And then you cast that to an int. And when you cast a primitive double to an int, that basically means put this double, fit it into a smaller box. A smaller box is an int. Ints don't have enough data to support the precision of doubles. So it basically, the int effect is it chops off all the numbers past the decimal point. Gives you an int, right? So where this returns 1 point blah, 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 if you cast it to an int, it just gives you a 1, right? And if you look at the maximum output of math.random, like 0.99, if you multiply 0.99 times 3, you're going to get like 2.9 something, right? So if you truncate that by converting it to an int, you get 2. So you get 0, 1, and 2. That's your valid thing. They're going to be put into your index, right? And so that's the trick, right?
So it doesn't round, it just chops.
Yeah.
Okay.
Yeah.
You could also,
Round it.
I was thinking like I wanted to initially get a double and then round it into an integer. That's what I want to do.
yeah,
Yeah, but
if you want to go that approach, sorry?
If you rounded like 2.7, then it would give you an index of 3, which is outside the array limit.
Correct.
That's
That's
an exception.
both of you, fantastic points, right? Will, I love how you tried to convert to a string because we've been using lots of string conversions to ints in class. So I can see exactly where your mind went with that. Great thought. The math.round, if it's greater than like 2.5, it's going to give you an index of 3, which is outside of that bounds of our array. What we need to do is floor that number. So if you have a double that is 2.35, right, and you call math.floor that double, it's going to give you another double that is 2.00, right?
Okay.
So if you didn't want to do that explicit int conversion cast thing going on here, then you could do that. And then you can, I think there's an integer.value of that takes in a double if you didn't want to do the casting. Right?
If we wanted to return it as, if we wanted to do a string instead of an integer,
Okay.
how would that change? Specifically, line 13 and line, the one above, 11.
So these two lines, right?
So again?
So you're saying these two
Yeah,
lines?
yeah.
So what you're saying is if instead of an array of ints, if we had an array of strings, how would this change?
To return a random string.
It really doesn't matter what type the array is. Because what we're doing when we try to build an index is try to build a random number to access our array. So whatever the contents of the array is kind of irrelevant at that point because we're just like the index can always be an int, right? So to index an array, you go from you get the left bracket and then a number and then a closed bracket, and that number can be anywhere from 0 to the length of the array minus 1.
Right. So I mean, but in here, like, I would replace int with, everywhere where it says int, I would replace it with string, right?
Not exactly.
Oh.
So when in this process where you're trying to build a random index, you have to keep those as ints, okay? Where you would replace ints with strings is in your method signature, right? So if you wanted to take in an array of strings and you wanted to return one of those strings, you have to say, hey method, what you do is return a string and accept a string. Or if it makes more sense, accept a string and then return a string, right?
Then what would you do with the ints?
The ints are for your array access. So this int right here on line 11 that we're defining is going to give us a number, an integer, between 0 and the length of the array minus 1. And we're using that random number, which is going to be for 3, an array of like 3, 0, 1, or 2. We're going to pass that into our array.
Even though it's taking in a string?
Yeah, well, so the array, the value at those elements in the array can be any type. So like, if you had a string array, if I had an array of 3 strings, and I want to get the first string, okay? The way I would get that is string array, that's a variable type, open bracket, a number. It would be 0, it would get the first one, and then close bracket. If I want to get the second string in the string array, I go string array, open bracket, 1, right? It's the second one zero index though, so you start with 0. And then if you want to get the third element in the string array, you go string array, open bracket 2, right? And each of those references would give us the string at that element in the array. Okay? Sense some existing confusion about that. Let's just talk a little bit about this. So we have a random index. We don't want to return exactly what we inputted because that doesn't do anything, right? It's not the right return type either. So what we need to do is use this and access the element that we got from our previous invocation on line 11. So how would we do that? Well, numbers is an array.
It is.
Do you remember how we get an element out of an array?
I was trying to figure out.
Don't worry about line. Don't worry about that, man.
It's not numbers.
It is numbers. We could just deal with this all on this one line here and then return statement. So let's not worry about anything. Let's just focus on this line right here. What are we going to return? An integer. What does numbers have? Yeah, numbers is an array of integers. So we want to get one integer out of our array of integers, right? The way we access integers, or the way we access any element in an array is through a number, right?
Yes.
And we have the number inside square brackets.
Since it's random, would it be I?
Oh.
This is it.
Yeah.
Oh, nice.
Yeah.
Oh, man, I was looking for a method for like numbers.get, and then
Nope.
take in the index number.
Yeah, that's like more like array lists.
Yeah,
For arrays, there is no method. It's just open bracket, a number, close bracket.
So if you like call this, it would just return 1 every time?
Yes.
if we have some that specifically would return whatever is the first element of your int array.
100% correct.
So if you change the int array to 517, okay, so you're plugging in the random variable that you use math.random to generate
Exactly.
essentially.
Yeah.
Pull the element out of the int array at that index.
Mhm.
Okay.
Nice.
Cool.
Nice phrasing. Exactly correct. So you can see with this logic is it doesn't really matter what the array type is. It could be ints, it could be doubles, it could be strings. No matter what it is, we're accessing the elements of that array with an integer. So we build a random integer, we get that element in the array.
Can you do one tiny thing and just point to where, if I were to change it to a string, point to where I would actually change the word to string?
You would, well, can you answer that question? If you wanted to change this from an int to a string, how do we update this method?
Do the whole method.
Yeah,
Like, it's
I can do it.
I'll let Mike
You
check.
have
He's
to put
very,
it in the
Like-
post static.
Do it.
Yeah, like
Do
right
it.
here.
Alright,
yes, right there. Oh yeah, Will's got it.
go ahead.
Right there.
Go with it.
So we want to accept a string integer, a string array ints, or we want to accept a string array and we want to return one string. That's how we want to change this method.
String.
Yeah.
You want a string here too?
Yeah.
A whole, you're returning
You
string.
return a string from a string.
From a string, and then you have to change line
It's
6.
just strings.
Don't worry about the call. Like we're working on the method signature.
Oh, okay, so then you just want a string here.
No,
Yeah, that's where it gets confusing.
No,
too.
yeah.
that should stay an int, because you're,
Right.
you need an int to,
But I'm kind of confused then there.
Because-
If we take in a string, how is int random then? Where does it even come from? Because it's a string that you're working with, right?
So
But are you casting there? Is that why?
This still gives you the spot of your arrays.
yes.
yes, which that has to be a type.
Okay, so that gives you like the
You
location.
put it in
Yeah,
line of like-
yeah.
Okay.
And
So that's just like cubby holes.
Okay.
Right? So there's 3 cubby holes here if we pass in 3 numbers to this method. These cubby holes have numbers associated with them, like a mailbox, right, almost. So 0, 1, and 2 in the cubby holes. It's just the addresses of that object, right?
Okay.
So the cubby hole can store whatever. It can store people, it can store ATMs, it can store text adventure players or characters or enemies. It doesn't matter. How do you say, give me, the first one is array element 0 with brackets.
So you do it through an int.
Yes, yes.
Okay.
Yep.
All right.
And so the int, you pass it into your array, it gives you whatever you stored at that array element.
Got it.
Yeah?
Yep.
Mm-hmm.
But can you leave that up for a second so I can write that down so I can?
Sure. Well, it's mine's very similar. It's in the scratch pad. We'll push it to the remote today. What's up?
Can I post mine in so you can tell me what's wrong with it? Never mind. I think we're,
So you tried to change it to a string? Yeah.
and I think what I missed was the.
Well, yeah, exactly. Yeah, we'll just wrap that in the print line. You're already doing. Just like cut this out of this line, 1.6, and just paste it inside your method call. And just take all this nonsense here. Not nonsense. Take all this code and then just paste it inside the print line. And run it. Oh no, wait, get rid of the semicolon here. Yeah, now run it. So you get 5, which is a weird string to print. Because it looks like an int. Yes. But still did the job, right? You can replace this with Ben will, yeah, whatever. People. Class.
Players. Sorry. I don't like that one because I like that like expands it for me.
Yeah. Nobody.
Inventory.
Actually, Nobody is a musical artist that I love. It's a song called, I totally forget. But it's amazing.
Return nobody.
Oops, I did it again.
Uh-oh. Keep trying, man. It's unlucky. Let's go until it gets, there we go.
And then it would be that.
Okay, so here is it. It's the practice problem. What's up,
Will
man?
we leave it up for 2 seconds?
Sure. Sure.
It's like exactly the same. What's the issue?
Do you want to share your screen? Go ahead.
You can expand if you want.
And will and nobody.
There's nobody else in the room.
And no one else.
I really wish we had other names to draw from.
All right, dude. Oh, that is special.
Oh my gosh.
Okay.
I know that voice. That's the voice of it was one character that was wrong.
It's done. It's big. Well, you got one more.
Okay, we all set on this? Yeah. Let me show you what I did.
And Britney Spears like stuck in my head now. I didn't work.
You got stuck in the game?
Got lost in the game.
Right, lost in the game. You think I'm in love? I've been sent from above. All right, I'm going to share my screen again. Oh, I accidentally shared my screen in Google Plus before I projected to Apple TV. Oh, it works. It's still working. Oh, God. Okay, we're good. So, check it out, guys. You're going to see this from now on. I don't have anything in main. What I have, you're not seeing anything right now.
I'm so lost right now.
I forgot to turn. I forgot to turn mirroring back on. Sorry.
It's like I can't.
I thought you were seeing what I was seeing. You were not. All right. So check it out. We don't have anything in main. Main is nothing. That's nothing. We're going to run our test. So from now on, what you're going to see is when I run my solution, it's going to be a test of my code and not something that's executed through the main prompt, which is a more appropriate way to do things. If we look at our test, we can double click here in the test run pane. I'm calling gimme twice, right? The first time I'm passing in our sample input from the lesson, and then I'm asserting it's true that either it's 5, 1, or 7. And then I'm doing it again just for good measure on several variants of numbers, like I included a -1 and a much larger one. And so I'm asserting that it's true that random int is either 232 or it's 23,483 or it's -285.
This is going to be online, right?
Yeah. So if it's not the case that gimme returns one of those numbers, I know that gimme doesn't do what I want it to do. So that assertion will fail. Actually, wait. Yeah.
So in the second line where it's so line 16 and 17, you just pick those numbers at random because one was a negative number and one was much larger. So
Yeah.
if there was going to be a problem, maybe that's something that would
Sure.
throw a problem.
Yeah, that's exactly my thought process when I wrote it.
All right.
This is by no means a comprehensive, like,
0,
I mean, yeah, you could use
0,
any number. Yeah.
0. Okay.
Yeah.
All right.
So I just want to give it a couple different test cases. If you're building a test, it's important to pass in whatever like realistic variables you would expect. Like in every case that you have like an if statement in your code, like you want to test inside your method, if you want to test if that if statement runs and if it doesn't run. So whether or not it runs is based off of your inputs, hypothetically speaking.
Yeah.
So you'd want to test an input that ran the if and then one that didn't run the if. Okay.
So I mean, if you're making a test for the weekend homework assignment ATM, you would want to have a line that tested existing customer, and then existing customer does it recognize that?
Yes.
And then does it then go through all of the prompts for that?
Yeah, that's a little trickier.
Okay.
We'd have to, in fact, I'm not even sure how it would test like terminal inputs and outputs. You'd have to probably pretend you're a stream and then put that in your program.
So you're saying that there's no way to set up a test that automatically answers the prompts?
There is,
Okay.
but you have to set up your program a little bit differently.
Okay.
So the way that the program is set up in the ATM is when you build a scanner, it's based off of system.in.
Okay.
How I would change that to be testable is probably something that accepts a scanner. So like if that method, if main, like for instance, maybe if main had a constructor and I could give it a scanner to use,
Okay.
then maybe it can be tested. Because in my test, I could give it a scanner, and the scanner could point to a stream that I control, right?
Okay.
And so the test itself could present the stream to the scanner and then put in its own numbers, okay?
Okay.
So because the scanner, we used the same scanner class for files as we did for inputs,
Yeah.
right? Terminal inputs. The only difference was what we passed into the scanner. In one case, it was the file F object. In the other case, it was system.in, right? If we, in the ATM's example, the scanner accepted a system.in, right? We think back. We can't do much with that with our tests because we can't necessarily simulate someone typing something into the terminal,
Okay.
which would come in through system.in, right?
Okay.
So to alter, like there's code that is testable, and there's definitely code that is not testable. You can't just go and test code all the time
Yeah.
with no questions asked. There is a way to architect your code such that it becomes testable.
Okay.
And how I would update the main class in the ATM project to be testable is to not just use system.in blindly. It would be to like update the method to take in a scanner. And so that scanner would like work on a stream, and I could build a stream in here in my test and just present it with a stream of values. So the scanner would read those appropriately
Okay,
and then work the same way as it did for the system.input.
okay.
Does that make sense, Mike?
Yeah, I mean, it makes sense. It's just, it's, when I thought test, I thought, we're gonna set up a test to test every possible scenario of walking through the ATM. So a new customer, create a new account, existing account, does that, do the withdrawal? and
Yes.
track it, And, you know, every iteration that you possibly go through, which would be
A lot of tests.
a lot of different ones.
Right.
So I was like,
Well-
that would be ridiculous to write.
Yeah. So here's this. If you like, that would be a hard test to write, right? Because you'd be testing one method. That method is main, because you have just method that does a monstrous amount of things, right? Usually, methods, they should perform an action, one thing, and they should return, like the results of whatever they computed, or they should do a thing and then leave, right? In main, right now, since we're not focusing on architecture of our programs, it does everything, right? So testing that one method is a huge task. You get to like test main if with this parameter and that parameter and these parameters and those parameters and all over the place. And there's probably lots of parameters where, you know, I mean, it could be that it's unreachable in some cases. But what that says to me is that main method is ripe for refactoring into its own set of methods.
Okay, so when you refactored it, you could write tests for each
Yeah.
method.
Yep.
And make sure that that works and is sound,
Yes.
and that way you wouldn't have to run through all of those, because you know that parts are all sound to make the whole.
Hey, man. Ben. Yeah. I don't think Marty's here right now. I think maybe he'll be here later today. I'm not sure. Have you guys seen?
Yeah, I'm sorry to interrupt. I had 10 o'clock set up on that.
Okay, what's your name again?
West Hutchins.
Wes Hutchins?
Yeah.
Let me hit up. Do you have his number?
I don't have his, just that.
Okay. If you just want to hang out for a sec, I'll reach out to Marty and see what he's up to.
Okay.
And then I'm sure there's some misunderstanding. I probably just don't know what's going on. Yeah, it's all right. Sorry, class. Was gonna message my boss. All right. So when I hear back from him, I'll let you know. That's all right. Okay. So, right. If you break apart your code,
And you know that part A, part B, part C,
yes.
all work and are sound, then when you put them together, they work.
Yes.
You know that.
Right. Exactly.
Okay.
Yep. And you might end up writing the same number of tests that you did before, but it's much easier to reason about them if you break them up into methods that do their own thing. Like if you have a method that's supposed to do one thing, it's really easy to write a test that does that one thing, right? It's not easy to write a test that tests the main method if the main method does like a million things. Yeah, right.
That makes sense.
It's overwhelming and dumb.
Yeah.
Be hard. Okay. So if I go into Gimme, it's very similar to what Will had. I have an example where basically it uses the truncation thing. I've added a little comment here that explained the whole idea of random number generation, passing it into multiplying a random number times an int, like the numbers.length will give us a number that is between 0 and that int minus 1, right?
I'm looking at is floor a method that's already in that?
Yeah.
And that's the one you're talking about?
Yes.
Okay.
So math.floor, if we look at the definition, I'm never not going to make sound effects, so you guys are probably going to have to deal with it. All right, so returns the largest closest to positive infinity, double value that is less than or equal to the argument and is equal to a mathematical integer. So that's a pretty verbose statement that basically just says
It rounds down.
it rounds down to the previous integer. Yeah.
Or is it?
Which if you round it up, right? So you did why you need to round up.
Hey, Wes, Marty says he's downstairs. Oh, there he is.
If your random number that's generated or it's mapped out random gives you 0.9 and you multiply it by 3, it gives you 2.7 and round it up, and you can get that number 3, which doesn't exist.
Yeah, so you don't want that for your array.
Exactly, so you gotta round down. That way you never run into it.
Or, you know, this is essentially the same. Like line 19 and 20 are basically the same, okay? Except it just might make more sense to people logically because you're like taking an integer that is a double and just making it an int and removing the 2 zeros, right? This is like the output. Well, actually, you know what? We have our Groovy console. Let's just run it. So if we have math.random times 3 and we run it, we get a bunch of random stuff. In this case, we got 2.0 something, 1.5, 0.69, 0.5512, right? So if we wanted to make this, we could cast this to an integer. We get 0, 2, 2, 0, 2. Come on, 1. There we go. 3 ones. Okay, 3 ones in a row. So the reason why it's doing that is because if you remove the cast, because it's a number like random between 0 and 2. So when you convert a double to an int with a cast, you lose precision. Right? So if I had a double like 2.58786, and then I casted that to an int, it's going to give me 2. And if I casted that back to a double, it would give me 2.00. Right? So if I had math.random times 3, so math.random times 3 would be 0.17 in that case. Cast that to an int. Yeah, that's a pretty high one, right? So int math.random times 3 would give you 0. If I casted that back into a double, it's going to give me 1.0.
Wow, so I didn't even know you could cast 2 times.
Yeah.
You don't need to cast 2 times. That was just an illustration to show you what.
I didn't know that.
You can cast as many times as you want. This is totally unnecessary, but you can do this. Yeah. I think maybe let's convert that to a char. And let's convert that to a Boolean.
True.
Yeah. So what this means is we have an int, and then we're converting that to a double a million times that does absolutely nothing. So this is like 0.0, 1.0, 2.0. We're going to convert it to a char, which has a character value. And then I don't know what the conversion to char to Boolean is. It's probably, it's a 0 or a 1, probably. It's a 0 or anything else.
Yeah.
So 0 is false. Everything else is true.
That makes sense.
So you take the Boolean away, what does the tar give you as a result?
Either a 0 or a 1. Or absolutely nothing.
Oh.
Interesting. Oh, it's a character that's not displayable on my terminal. So I saw here is a character that it looks like it's missing the character.
We have a guest speaker today at noon.
We do have a guy coming in. I'm not sure what he's going to be doing here. I'm not sure if he's going to be talking. Let me review what the Slack message was. I know his name is Drew, and I know that he's interested in working here.
So he's not getting
No, that's Wes, which is weirdly the same name as our previous campus rep.
Yeah.
Yeah, it shouldn't matter. It's not, it'll be hot.
Okie doke. All right, so this casting business gets a little complicated. We covered casting a few days ago, but I feel like we need, that was a preface too. I feel like we need to review it.
Well, I mean, I think I got it.
Well, casting for these primitive types is a little bit different than casting for the actual classes. Okay. So check it out. So remember, we're missing a few people. Well, we're missing Jennifer too. She's not here either.
Probably the bathroom should be right.
Yeah, go on with that.
She is making a human currently. Right now, she's making a human. So yeah, that's why we don't ever like.
It's like
That's weird how you put that. That's amazing.
Well, Mike said it. Mike was like, she's making a human right now. So she basically has free reign to do whatever it takes to make that human. All right. Casting. So remember how we had in previous assignments recently, we had the create item and you had a create book method, right? And we talked about polymorphism, we talked about inheritance, right?
yes.
Okay, so a cast in normal situations is not going to take place in these primitive types, right? Those are, I mean, it will happen in some cases like what we just talked about, but it's not as common as a cast for classes that you define. So let's talk about our text adventure. We had character, we had enemy, we have player, right? Those are the three classes that we have. So character is the base class for both enemy and player. So I'm just trying to figure out how to represent this in ASCII. So we have character, enemy, and also character, player, right? Let's do double colons because I just like that better. Okay. So character is the base class for both enemy and player. So if I have a method, so character object equals character.create object, and I give it, good guy, right? This is very reminiscent of what we had in our text adventure game. So if I create object and I pass it a string good guy, it's going to give me an instance of player, right? All players are characters, right?
How do you do the double symbol?
It's just in some languages that's actually how you write like a subclass for that has a superclass of character. So it's just me letting you know that player inherits from character, or it extends character. Okay. So we could go in and we could like look at the actual classes and say character or player extends character, but I just wanted to show you kind of like in pseudocode what we're talking about right now.
Okay.
Yeah. So if we get an object back from create object, it's going to be a character. That variable is going to point to a character. That character could be a enemy or it could be a player, or it could be a character, honestly. But let's just focus on enemy and player right now, right? So we know just in our minds that the result of good or create object we passing good guy is going to give us a player. So we can cast object as a player. So objects, think of it like, man, what's the example I typically use? The way I think of casting is like if you shine a light on something, it casts a shadow, right? Okay, so if I am a kid, right, which people would say is very accurate representation of me, and I'm, in a dark room at night trying to sleep, right, and it's storming outside. The tree branch, right? The typical like moonlight filters through the tree branch, creates like a monster hand on the wall, right? That to me is the kind of the gist of casting, right? So based off of how you see that tree branch, it can appear to be different things, right? So it can appear as a different type of object, right? Now in the real world, those things like the monster and the tree branch don't have to be related, right? It's just an example of what's going on here. So at the end of the day, as a kid, no matter what I thought that tree branch shadow looked like, it was always a tree branch. It was never anything else. in programming, if I return an object, that object's type is a player in this case, right? It's not an enemy, it's not a character, it's a player. It's just that we are allowed to reference that player object with a character variable. So we're like, hey, this object is a variable, it's gonna point to anything that is a character, okay? And so we're like, the character that we're choosing to point to is this player over there.
So like
Right.
the player is like the shadow, and the character is like a tree.
With the way I'm thinking of it, Will, and it could not to say that your impression is wrong, is that the player is the tree branch. No matter how you shine the light on the player, it's always a player. Okay.
Okay.
So it's cast because a lot of people have the impression that when you cast something, it changes its type, and that's just not true.
Okay.
Okay. It's like if you cast something, like if you cast an object to a player, like we're doing here on line 6, it doesn't turn object from a character into a player. Object was already a player.
Okay.
The only reason why we would cast is to make a new variable like player p equals new or equals player obj. Okay.
Sounds like Halloween.
That's what I was thinking. It is.
I suppose, yeah, it's kind of spooky.
You're
The tree
always-
branch.
You're always Ben.
Yeah.
But they could be cast as a.
Yeah.
As a
Well.
vampire.
So the rules for casting, okay? So say instead of character, enemy, and player, let's go down here and say we instead have shape, rectangle, square.
Okay.
Shape, rectangle, square. Okay?
Okay.
And say I had shape equals shape.create shape square in the same way we had before. And by the way, when we do this, when we pass in a string here and it gives you an object that is the appropriate type, this is a very common design pattern. It's called a factory. We're building factories.
That
It's,
makes sense.
it's like a factory for items. It's like I tell you what I want and it gives me the appropriate type, right? This is someone doing something. Like factory
I was
does.
thinking like Fraggle Rock.
Wow, that is a reference I haven't thought of in a long time. Yeah, that was a fun show. We might have to watch some Fraggle Rock over lunch.
Yeah.
Okay, back on task. All right, so if I have a create shape method, it returns a shape. Okay, so I have a shape object, or a shape variable rather, that points to a shape.
Does it always return a square?
Well, if in its imaginary method that we pass in square here as a string, then yes, it'll return square, right?
Okay.
But we could have passed in like a rectangle. In the event that we had, if we had a like, oh my god, like a circle, we had triangle, a triangle, triangle.
Oh.
All right, that's not, what am I doing? All right. So in the event that we have different shapes that inherit from shape, like circle and triangle, then we could be able to hypothetically pass into our factory like, give me a circle or give me a triangle or give me a square. And I
Can
give
we
you,
change that?
and what?
So you want to create a new shape, you could just leave that blank. And then you can add in whatever you want.
Yeah, I mean, create shape doesn't exist. Like we're totally hypothetical, so we can make it,
But if it did exist,
yeah, if we want to do create shape like that,
yeah,
well that, I mean,
we could pass in anything.
yeah, we could pass in whatever we want to it. Yeah, I mean, if we define create shape, if we want to be able to make shapes based off a certain criteria, we'd want to pass that criteria as a set of parameters into our create shape method, right? And if by saying it's a string, we're saying the only criteria we have is that we call it a square, right? If we passed in like, actually this might be a great example. If we pass in the number, like if we pass in like 3, so if create shape took in a number of sides, create shape could do returns to triangle.
Would it really?
Well, I mean, we can make it do whatever we want. So yeah. And then if we pass in a number of sides here, it could give us probably a rectangle.
How would you write that out?
Well, it would be something along the lines of public static shape, create shape, int sides.
Create shape.
If sides equal to 4, return new rectangle.
Oh.
Right?
Yeah. Great shape.
Yeah. So if size equal to 4, well, we have to be like full equilateral. Size
Okay.
equilateral. Because we also have a square that we want to return. So
Right.
if equilateral equal, there we go, then return new square.
Mhm.
So if the size count is is equal to 4, then we're going to return a square if all the sides are equilateral, otherwise return a new rectangle, right?
Okay.
So this example kind of took a life of its own,
Yeah.
but we just updated our create shape. We'll call this false. So if we wanted a shape that has 4 sides and does not have the strict requirement that the sides are equilateral, then it's going to return to us a rectangle object.
Awesome.
And since all rectangles are shapes, we can reference that rectangle with this shape variable. Okay. And if rectangle had a specific method on it, like if rectangle had a method called print rectangle details, totally arbitrary, right? We couldn't say shape.print rectangle details, rectangle. God. Rectangle details, right? Because shape is a variable. All it knows is that it's a shape. So we can't run rectangle methods because it's a shape. So what you have to do in order to run this is cast it to a rectangle. So you cast it to a rectangle, and then after you cast it, you call print rectangle details, and that'll be a valid method call. Right.
Well, I won't remember that last part.
I'll copy this and upload it to our lesson today.
So when you're
Basically, like, that right there is a rectangle. Because even though it's a shape, you cast it as a rectangle.
It was always a rectangle. So when you make a new variable, right, it occupies space in memory, right? When the object occupies space in memory, the variable basically is a signpost that says, this guy over here, I'm going to reference him as a shape. I know he's a shape and he lives here, right? So when you're looking at a variable, it technically is a reference to an object. So that object is the same object no matter how you cast that variable. So basically with a cast, you're saying, hey, you know you're a shape. I know that object is a rectangle. So as a rectangle variable, try to call this method. Because the variable, you have to funnel all your method access and field access through your variable. So if you call print rectangle details on your shape variable, the shape variable is going to be like, I don't have a method called print rectangle details. So go away, right? But if you're like, listen, I know, you're like, by casting, you're like, okay, I know that you think that this holds a shape, and that's correct. It is a shape, but I know more details about it. It's a rectangle. And so let's look at this object as a rectangle. Let's call its rectangle specific method, right? So there's a very subtle difference between a variable and the object it represents. In other languages that are older, like C and C++, this is a very distinct difference. Java glosses that over because those are very technical details that sometimes can drag you down. So to pull this all back together, casting has rules. And I'm tempted, I wish I pulled that. Remember the Big Lebowski when that guy said, am I the only one around here who gives a shit about the rules? You can't just cast an object into any other object, right?
Okay.
I can't, if I was given a triangle object, I can't just cast it as a square.
Okay.
So if I called create shape 3 here, we know in our minds that the polygon, the shape that has 3 sides is a triangle. So we know this shape variable is going to point to a triangle. And on line 19, we're going to say, hey, shape variable, pretend you're a rectangle, and then call me and then call print rectangle details. And at runtime, your program would be like, whoa,
You can't do that.
you cannot convert a triangle to a rectangle because they don't have a parent-child relationship, and that's the key.
So you can't go between lines 12, 13, and 14, but you can go any which way you want on 12. So you could go rectangle, because a rectangle is a shape,
Yes.
so you wouldn't have to go that way, but you could go square to rectangle, or rectangle to square.
Yes.
Right?
Yes.
So you could flow back and forth that way, but you couldn't just.
Yes.
I got it.
Yes.
You also
I
do
don't
the
know how
same.
to explain it.
I know, but you got it.
I think I
You
got it.
also do the same with character, player, and enemy. So because they're both characters, could you do that?
Yeah.
Okay.
Yeah. I mean, you can convert between a character and an enemy, and a character and a player.
Okay.
You couldn't convert between player and enemy.
Yes.
But you can compare apples and oranges. You can't compare apples and
Yes,
onions.
you could, or yes, I know what I.
Yes, you are
I was
correct.
stating.
That is a correct
I was
statement.
stating the statement that is true.
Perfect, Mike.
Okay. All right,
Yeah.
got it.
Okay. So, like Mike was so appropriately saying, if you describe this class inheritance like we are on lines 12 and 13 and 14, if you have a shape object, you can cast it to a rectangle, and you can also cast it to a square. But if you cast a generic object, like a base object, like a shape, into something else, like anything it's because if you have a shape, if you look at this inheritance tree, it's possible that you could cast it based off of the return type of create shape. You could cast it into any one of those other classes, like rectangle or square or circle or triangle. You won't know until the program executes what that create shape method will return, so you won't know that cast will throw an exception until it runs, right?
All right.
So that is, in a more generic sense, if you're ever casting a base class to one of its subclasses, or if you ever class a superclass here being shape, into one of its subclasses, rectangle or square, you run the risk of having a runtime cast exception, like you can't convert this shape into a triangle, because inherently it's not a triangle, it's either a rectangle or a square or circle.
So is the original shape then the superclass? It's just any shape?
Yes.
Okay.
It's any shape. It's not safe at runtime to just go wildly casting your variables, which is why Java introduced a language feature. There is a keyword called instance of. So if you could say if shape instance of rectangle, and then we put our rectangle goodness in that is now a safe thing to do, because instance of will return true in the case that this object is a rectangle. And then we can cast that as a rectangle because we know it is a rectangle, and then we can call print rectangle details because it's a rectangle variable at that point.
That makes sense.
So yeah,
If it wasn't a rectangle, we would just skip that, and say that we would come back to the wall.
yeah. And if you needed to print rectangle details, you're like SOL. You should have given us a rectangle object.
Yeah, sorry.
Right?
Figure it out.
Yeah.
Okay.
So it's not always safe to do I always get these confused, downcasting and upcasting. The terminology that you're going to use for casting is downcasting and upcasting, right? So I believe upcasting is when you cast up to a super type, and downcasting is when you cast down to a derived type. Yeah. So I need to confirm that. But basically, if you cast, you can always cast a square to a shape.
Yes.
If you have a square variable and you want to cast it to a shape, that's always valid, because every square is a shape.
So no matter what the technical term is, you can always go from sub to super.
Correct.
Okay.
Yeah. So if I have a circle variable and I want to cast it to a shape, that's valid. If I have a square, I want to cast it to a shape, that's also valid. If I have a square and I want to cast it to a rectangle, that's also valid,
Okay.
right?
But you might run into an exception if you try to go shape to square, because it might be like, whoa, you don't meet the
Yes.
criteria for square.
Yeah, because this object is not a square, right? This object, if this object has its class as a circle, then you can't make that cast. So I know Mike gets it. which is awesome. Great job, Mike. We're probably gonna have to come back to this, right? I'll upload these Groovy notes to our lesson today. All right. Cool. Are there any questions that you guys can formulate right now about casting? Because it might not be solidified, but you might also not be able to know what question to ask yet, and that's totally fine. We can come back to it later as well. Okay. In that case, let's move on a little bit. Let's go to our today's lesson. We're not going to we're going to introduce a new concept today, but it's not going to be incredibly intense on lecturing. We're still sharing in Google+. We're sharing the window. Let's go ahead and share everything. What's up, homies online? All 0 of you. Whee!
Oh, yes. I like your last cohort cheat sheet.
Oh, yeah?
Yeah. I looked at
Thank
that
you.
last night.
Thank you for putting that
That
up.
was,
Was it good?
this seems very helpful, yeah.
Yeah,
Nice.
that's great.
So at the bottom of it, I need to fill it out with more information about packages and stuff, but it seems to help people get a sense of context and stuff like that.
Yeah, I mean,
So-
the basic outline, it looks like a great place to start.
Yeah, cool. Rock on. I'm glad you guys liked it. Okay. So I'm going to start with today by looking at our forum project we did yesterday. Oh, wait. Crap. Hopefully that didn't just wipe off my Groovy console. No, it didn't. Thank you so much, IntelliJ, for not sucking and saving me from my own mistakes. Okay. So Groovy console. Let's go back to our main method, or our main class, which has a main method. And let's talk about this. Let's remove, first of all, this arbitrary stuff we have there. So the main method right now is responsible for a lot of stuff, right? It makes a new post variable. It makes a new file variable. It scans that file. It populates our post array list based off of the contents of that file. And then afterwards, we, for every one of the posts, we're displaying that post, right? That post ID. So this is a lot of work for one method to do, right? It's responsive. I mean, it's not that the Java language can't handle it. The computer can easily handle it. It doesn't care what method you're in. It's just from a human readability standpoint or maintainability standpoint, it doesn't have a whole lot of flexibility. Because if you wanted to do one thing, like open up the file for reading and not do the rest of the stuff, it's impossible, right? Sometime down the road. So it's good practice to, what's up? Oh,
I'm just saying, I'll be like,
yeah, no, it's cool. It's fine. Stand up. It's cool. So usually your methods, like I said previously, they should have one responsibility. I guarantee you that if you architect your code in such that your methods have one job to do, and that's it, you're going to thank yourself later. The more your methods do, the harder they become to maintain. Okay, and the less flexibility you have in your code base. Tic Tacs remind me of the movie Juno. Remember Juno? Bleeker used to eat Tic Tacs. They were orange though. Okay. Yeah, I remember loving it. All right, so right now we have in our main method on line 11, we have array list posts equals new array list. And then later in the method, we're replacing posts, or we're adding to posts the contents of our posts, right, from our file. So say we don't want to do that anymore in main. We want to delegate that responsibility to read file. So based off this line here, read file we're setting post equal to invocation of read file. Read file takes no parameters, right? So what read file needs to do is, without any parameters, give me an array list of posts, right? So let's do that. Read file. Okay. So it doesn't exist yet, so IntelliJ is like, what the H, bro? So if we go here to public static array list post read file, that no longer has that red reference because we defined what that method is. So just like we can see here that we don't accept any parameters into read file, and that we can assign post equal to the output of receive read file, that it has to have this method signature. It has to return an array list that has posts in it, and it has to accept no parameters, right? So let's take our code that we had for reading a file and kind of put it into this read file method. So we have all this guy here, here. We have to specify that read file can throw a file not found exception, because without that, the scanner indicates that we need to either handle that exception or throw it ourselves, right? So if we specify a file here that doesn't exist, our scanner is going to throw an exception and be like, I'm not going to be able to scan this because this file is not valid. So we got to either handle that in here or throw it ourselves. Okay. So one weird thing is that, you know, this post variable is red now. Because this post variable doesn't exist, it's inside this method, it exists inside the main method, right? We're assigning posts now. So what we need to do is, in this method, make like a variable that we're going to return. And then what we need to do is we need to operate on that variable that we're eventually going to return. Up here, we're saying on line 32, we're making a new results variable equal to a new array list. And it takes in posts, right? And at the end of this method, we're returning that results method, right? So in the body of our method, we're going to be updating posts with what we know to be the contents of that file.
You'll have a new array.
I have a new array list here. Yes, new array list, we're labeling it, we're making a new object called array list, and we're assigning the results variable to that object, right? And then we're using our results variable, we're calling the add method on it, and we're passing in a post. Yeah, and so it's the same array list, it says we're making a new array list object, and then we're calling the methods on that object to update it, add posts to it, as we read them in from the file. Okay, so at the end of the result, we're going to have all the posts that existed in the file that we opened. We're going to return that back to main. So on line 13, or after line 11 executes, posts is going to be whatever was returned by read file. Excuse me. Right? Okay. So that's step one. So what we're going to do now is do the same thing for the code that prints all the posts, okay? So we have console scanner system.in. We have a reply ID, which is used to break in or out of the loop. So if we want to consolidate the logic for printing the posts data, so we look at what we have here. we take all this stuff here, and basically encapsulate it into its own method. So the method we're going to call is print posts. And we're going to give it a post, and we're giving it a reply ID. So keep in mind that we're passing in a reply ID from input, and then we're giving all the posts that reply to that ID. Okay, so each post has an ID that it's replying to. Okay. So in order for print post to do its job, it needs to know all of the posts, and it needs to know which one that post is replying to. Okay, so let's check it out. So print posts, when we invoke it, we're not assigning it to any variable. We're not saying print posts equals whatever. So we don't have to return anything in our method call here, right? So we can say it's void. Its job is to print data. So we have print posts. Print post takes in 2 parameters. The first parameter is, we can see here from our invocation that it's the post is variable, which is of type array list of posts. We can call it like posts just for consistency's sake. And then the second thing is a reply ID. We see on line 15 reply ID is an int, so the second parameter is an int reply ID. We'll just keep it consistent as well. We'll just paste this in here. And we can return optionally, but we'd have nothing to return, so we can remove it. So for every one of these posts, okay, and then this ID thing is a little strange. I'm not sure why we're doing this. Let's get rid of this ID for now. Actually, no, we'll keep it there because it's going to mess up our notes. Do something with it later. So for each one of the posts, if the post is replying to the current reply ID, so like if I have a post in my post file, it's like here. So post.txt, this is each one of these lines is a post, right? This is replying to the post ID 1. This is replying to the post ID 2. But the purpose of this for loop is to figure out, based off of which number, like what messages were replies to that number. Okay. So we took that logic out of the main method and we put it into its own method. That method's only job is to print these things, right? It does nothing else. So if we wanted to print them later in some other context, then we could, without running the rest of the main method. And if we wanted to read the file and do nothing else, we totally could now because we have that method. It also makes your main method look way more concise. Like it looks, it's not overwhelming to the reader, like what exactly is going on in the main method. Okay. So I encourage you to look at your methods, and if they become too big, see if there's units of work that can be done. You can abstract into their own methods, like we just did here for read file and print posts, right?
What you just did, would you consider that refactoring? Because like you haven't moved anything out of main, you've just made static methods in the main class. And then called those.
Yeah, it's not a requirement of refactoring that you make a new class.
Okay.
The only thing refactoring means is that you, it's basically like maintenance work. It's like this works, this code works, but we want it to maybe behave a little better, like make more sense, right? So it would make more sense if this were over there, right? You know, or instead of over here. It's like rearranging your room, right? If you're not comfortable with how the room works anymore, you can like rearrange it so that it flows better, right? It makes more sense to you. That's basically what refactoring is.
Okay.
It's not quite the same as bug fixing. It's like this thing already works. We've already done this feature. It's just we want to re-architect the code because we know we're going to want to do something with it later on, right? Make it more clear to the reader.
Exactly.
Like
So
Yeah.
passing this on to my boss and I want to know what's going on.
Yes, that's another thing. It's a great reason to refactor your code, is that you've solved the problem.
Yeah.
And in fact, I'm so glad you mentioned that, Mike. So a very common thing we do in programming is get your task done. And then after you get it finished, go back and try to improve what it looks like and how it flows and stuff like that. And that's where using unit tests really shines, right? Because what happens is this is called test-driven development, right? So if you write your test first, before you write your functionality, your test is gonna fail, right? Because you haven't written the functionality yet.
Okay.
It's gonna fail.
Makes sense.
So you do what you can, like don't make it fancy, make it work. Make it work. Get your test to pass. All right? Once you get it to pass, you make a git commit, right? And then you're free to modify that code however you want. If you want to refactor it all day long. Worst case scenario, you mess up everything, you revert back to what you had before. It still works. Best case scenario, you figure out a better way to do what you did, and you make your method way better and you commit that change, right? But you're always backed up. You don't have, you solved the problem already, and no matter what you do to this implementation, it still solves the problem because you can run a test and confirm that it does exactly what you said it should do. It's a really great way of thinking about code.
In the real world, would your boss set the test
No.
for you? You know what I mean? So
It's interesting.
basically it's I want it to be able to do this and pass this test. You figure out how to do it.
Lindsay brought up a very similar concept yesterday. It is not common that someone else is going to be writing the tests for you.
Okay.
I'm not going to go ahead and say that never happens because it's legitimately a possibility. But frequently you are tasked with, okay, so the way stuff works when businesses tell you to write stuff, they give you a list of requirements, right? They're not technical people, so they can't write the test for you. Can't even come anywhere close. They don't even know the concept of tests, right? Okay? So as a programmer, you'll work with them to build that list of requirements, okay? Features. And then you might have an estimation process where you're like, it's going to take X number of time. Agree on that. And they'll give you a deadline based off of that. And it'll work, right? You're going to take that list of requirements, for each one, write code to fulfill that requirement. So now you're in code land, right? You want to write a test at the beginning of fulfilling this requirement because you want to make sure that it works, so that you don't accidentally make a bug and then you say it works and then it doesn't actually work and then your boss gets mad at you, right? So for this feature, you're like, well, I'm going to probably need this class, that class, and the other class, and then you'll write a test, and then you'll write the functionality, okay? And at first, you're not focused on making it look pretty. You're like, just get it to work, right? It's like writing everything in main instead of refactoring into its own methods.
Yeah.
And then, if you have time, you go back and refactor it and make it look nicer, right? But if you're under a strict deadline, you know what works, get out of there. Go to the next feature, right? You have a series of requirements that this thing needs to follow. But if you want to come back to it and refactor it later, you're always free to do that. If you remove tests from that equation, you are not free to refactor your code because you don't know what you've broken when you change anything in your code at that point in time. So that whole process totally falls on its freaking face. And if you don't have tests, you basically can't modify that code anymore after you write it. You just can't touch it. Because you can't guarantee that it works or not later if you try to refactor. So it's kind of a no-brainer to use tests. But I guarantee you that if, 6 months down the road, all of you are in jobs, writing code, 4 or 5 of you won't be required to write tests for your code. right? It's kind of lame.
I read this, so I was reading all of these, because I'm kind of lame. So I was reading all of these like tech quotes, and there was this one guy, I can't remember his name, he was talking about how like refactoring isn't a concept that he uses because it should be done immediately. Like he was like, it should be done while you're making the code.
That just seems like a stupid thing to say.
Okay.
I mean, that just is like one of those, like, that's his approach.
Sure.
Like really meticulous.
He could be a highly effective programmer. I'm not going to doubt his skill set. I'm not going to doubt what he's capable of doing. But I do know that he's a human,
Yeah.
and humans write things that are not perfect. And at some point, his perfectionism is going to make him want to go back and change what he's made previously.
Right.
So that by itself kind of disproves his whole thought.
He was like a really famous guy. I can't remember his name.
Famous programmer?
Yeah. Who was like really anti-refactoring.
Well,
Probably just
I'm not super surprised by that. Really famous programmers have a tendency to be highly opinionated.
Yeah.
Like, I talked about Linus before. Linus is this is going to be online, so I don't want to be like it's all unlisted. So the chances of someone seeing is low. But and also Linus knows this. Linus, you're a dick, right? But you know that. But you're a genius. So if you ever watch this, then know that. But like, yeah, I've seen. I mean, like it's. I can imagine someone who's famous in programming saying something like, you should never refactor your code, right?
Yeah.
But in reality, like, you're not always given an infinite amount of time to accomplish a task, right? In the business world, time to market is actually super important, right? So if you want to write some code that you want to make sure is functionally correct, you write a test for it.
I have it right here, actually. In almost all cases, I'm opposed to setting aside time for refactoring. In my view, refactoring is not an activity you set aside time to do. Refactoring is something you do all the time in little bursts. Martin Fowler.
Oh, okay. So he's not saying that never refactor.
Yeah, never mind.
He's saying that you shouldn't consider time in project planning because you already guaranteed functionality. So he's not discounting refactoring in that quote. He's just saying that there's other things that take priority, like building features.
Yeah.
Yeah, and making sure they work properly. And also, he's saying that it's just something that happens organically as you write code. Yeah. Okay, well that's good, because then I would have seriously doubted his any code that he's ever written. And I know Martin Fowler's name, but I don't know he's written. Look it up, Martin Fowler. Looks like he's got a lot to do with UML, which, Jesus Christ, that kind of makes sense actually. UML is a diagramming language that lets you map out what your class architecture is going to be. So like this inherits this. Some enterprise companies still use UML, but it's mostly dead. Okay, so it's 11:12. Yeah, let's take a break. I want to get into interfaces when we come back.
What time should we come back?
11:30. No, 11:20. Yes, sir. Not a super long break, but I do want to make sure we have enough time to talk about interfaces before lunch. Similar to inheritance? Is that what you just said?
Yes, I think that I've come across.
All right.
My basic understanding is that you can use it to change something without interject anew after you make something better.
Mike. Okay, yes, interfaces.
Well, I mean, we'll get into it. We don't need to talk about it.
It's okay, we can talk. I mean,
Take a break.
all right, yeah, actually, good point. Yeah, stretch your legs, get your mind relaxed a little bit. So, Avery, I know that discussion around casting was pretty brutal.
Yeah. It seems like we're doing a lot of day one stuff again.
Yeah, we're trying. I mean, it's well, it's like 2 steps forward, 1 step back sometimes, man. So, I mean, we're trying to push, but we can't push. We can't just be at that clipping pace without like review sometimes. So, I know it's not the easiest thing to talk about or listen to, but during lab time, we had the time to have maybe a one-on-one chat today. We can kind of go over some topics that might be more interesting to you.
Okay.
We're gonna get there.
Like the stream stuff, I think is interesting and everything, but without like a project to like direct my thoughts, it's sort of like, that's cool to know, but I haven't really done anything cool with it yet.
Yeah. How much do you know about the internet?
Not a lot. That's part of what I hope to learn this class.
Okay. Do you know anything about like what jobs HTML, CSS, and JavaScript do?
Yeah.
Okay.
Yeah, so like at my last job, I wrote HTML, Ajax, jQuery, PHP as like a front end interface for like a remote embedded system.
Yeah.
So like, it definitely wasn't like optimized or like the best it could be, but I like work, I know enough to hack some stuff together.
Yeah.
I've never used like Java as a backend web language.
But you know that's what the PHP was, right?
Yeah.
Yeah. Okay. So really, like we talked about before yesterday, someone else share the screen, or did the Apple TV just sleep? What has happened? I guess it just went to sleep or something. All right. Really, some of the biggest use cases for the Lambda expressions in the Streams API is, like we said, is data access, like collections analysis, stuff like that. Like if you have a list of collections that you want to distill a number from, or you want to get a certain subset of those that collection, Lambda expressions really shine in that case. And a lot of operations you do when making websites are very similar to that operation. Like if you want to get a certain subset of users, or get a certain subset of the users' posts they've had over the last week. I mean, that's a very common thing to do on a website because you want to display that information on the web page. That's where I think a large amount of the development around those Lambda expressions has come in the past, like 5 years, right? So when we get into the web stuff, and you're mentioning JavaScript and jQuery, we're going to go. I mean, we're not going to get super into that, and we're going to talk about JavaScript. We're going to have a few lessons on JavaScript. JavaScript is actually something I'm highly interested in. So like I read a lot of JavaScript, and I think it's really cool. So we'll go into that a little bit. We're going to get into like what makes a web request. Like with PHP, I'm not sure if it was quite as apparent. It may be like PHP. I've only really dealt with it as like a scripting language on the back end. Yeah. Like it just basically populates a template with data, right? And then you can query. Like it's all that in that one .php file. And it's not very reflective of a modern MVC framework. Yeah. So have you dealt with MVC frameworks at all?
Not that I'm aware of.
Okay. Do you know what MVC stands for?
No.
Okay. It's Model View Controller.
Okay, I have heard that term before.
Yeah, it's a pretty prevalent term. In fact, you've used that term in your JavaFX code. That's probably one of the reasons why you've heard it, right? Because JavaFX is a very similar process. It's not identical because that has this thing called, that's like a model view model. It's complicated, but essentially it's very similar to MVC. Okay. So in MVC, let me just tie this all back in. The PHP framework you probably used was a pretty simplistic one, where it's like you just write stuff to the screen conditionally, and the server processes those expressions.
More or less.
In the MVC framework, it's like a server that handles a web request, and then it maps that web request to an action. The actions are methods that live inside controllers, And then the action is responsible for getting data that it needs to get from a repository if it needs it, and then rendering a view. So that's the view, right? And so at the results of processing the view, you give the view typically a model and a template. And there's like various templating languages. So the view would look something very similar to what you would see in PHP, where there's like markers for put this variable in here. So you take that template, you pass it in a model. The system will process that template with respect to that model and fill out the template with the values from the model. And then you'll return that string as an HTTP response back to the client.
Okay.
And that describes the general flow of a HTTP request response pipeline in an MVC model.
Okay.
So the biggest thing that makes it MVC is the routing pattern. So what you're going to develop is what's called a routing table.
Okay.
It's going to map the relative paths to your domain to the route table. It's going to appropriately invoke the correct action for that.
Okay.
There's a lot going on under the covers because based off that action name, it's going to, by default, look for a view with the same name. So just typically it's just convention.
Okay.
And we'll get more into that later, but
Okay.
Yeah.
Yeah, so I've done some like Ruby on Rails stuff.
Yes.
That sounds very similar to that.
that's exactly what it does.
Okay.
Where did you guys get popsicles?
The last two downstairs in the freezer.
You guys are jerks.
They were there.
Yeah, okay, it is fair.
It was nice outside. We just sat out there for 2 minutes.
Honestly, I probably had been going with it.
Everyone had peanut butter. It looks so good.
Oh my god. I totally forgot about all the stuff we had from last Friday hanging out in the freezer, so.
Well, yeah, don't worry about it now.
I know, but we'll get more stuff tomorrow.
Somebody ate like the last ice cream sandwich. I had no idea.
Those mother effers.
I went down there and I was like, "There's one left."
Yeah.
It's
Sorry
gone.
about that.
Oh, that was Will.
Well, it was not. Last sandwich.
Oh, Will's like, about that ice cream sandwich. I was thinking it was someone else in that co-work place, so I'm glad that that's not the
No, they
case.
didn't eat anything after.
I thought it was too.
That's really surprising. Usually in an office environment, actually I've heard this, but I've never experienced it firsthand. Apparently it's a thing where coworkers will just eat your food if you keep it in the fridge, which I've never ever seen.
Yeah, my dad said like even if he puts his name on it, like people in his work will eat it. That's kind of
So
Yeah,
rude.
I
You are
have,
so rude.
I have never,
Nerd.
I have never experienced that firsthand ever. It would totally blow my mind if I'd be like, why
Have you guys seen that?
are we like animals that like just are scavenging in the fridge for some?
Like people
Have you guys seen that? Like I'm holding your ham sandwich hostage. Like meme. Oh my
Oh, I haven't,
god.
yeah.
It's so funny. Like, Ham, we know it's you. Please report to HR.
Yeah.
That'd be funny.
It's really funny.
I've actually seen, I think it's on ThinkGeek. By the way, ThinkGeek is a website that sells really awesome things. So just as an aside, as an April Fool's joke, they had a sleeping bag. It was a tauntaun from Star Wars. And then the zipper was a lightsaber, and you could unzip it, and the inside of the sleeping bag was the guts of the tauntaun.
Oh, cool.
And then everyone wanted one so bad that they started making them because it was an April Fool's joke, so it wasn't supposed to be real. And they're like, "Oh, we need to make this product." I had another thing to talk about. Oh yeah, speaking of people stealing your food, there are people that I know will make sandwich bags, right? And those sandwich bags have patterns that resemble mold.
Yeah.
Good idea.
Right.
Yeah, put that on sticky bar on the fridge.
And then the next time anybody wants to touch of it, don't mess with that.
Yeah, seriously.
I'm hungry.
Just like I'm teaching you a lesson.
I know, right?
I think that's actually like a pretty good approach because I've seen other approaches where they're like, I'll just lace my food with like some drug.
Oh my god.
Are you serious?
Yeah, or like not
Oh
maybe
my
not
God.
even illegal drugs, like maybe like a laxative or something like that. It's like I'm sorry you're pooping all day, but maybe you shouldn't have eaten my brownies.
Yeah, like if they keep stealing it like every day, put some laxatives in there, see who has to go to the bathroom like 20 times a day. Be like, it's you.
That would be awful.
You're using the bathroom a lot today, Bob.
I wonder why.
Guys, weird. So you've been going to the bathroom? That's weird. I've been missing my ham sandwich.
There's a correlation.
Is that related? I don't know. Sorry, Bob. Are you tripping balls right now? That's crazy. Because I put a bunch of LSD in my sandwich today. I wonder if those two things are related.
That seems like a really drastic punishment. Or like,
That would be so funny to see.
these are like screaming at me. Mom's like, I'm sorry, I took your sandwich.
Well, later he might say that, but at the time he's probably too busy like losing his mind, having the craziest trip of his life. Actually, I watched this show, Vice Principals, recently that, they, like, in last week's episode, they accidentally splashed a cooler full of LSD on themselves and they're tripping. Yeah. It's a,
That would freak me out. When I was younger, I used to freak out that like somebody would waste my drink with like LSD all the time. And my sister was like, seriously, Lindsay, who would waste their drugs on me?
real talk though, you should always watch your drinks.
Yeah.
And, like you never
It's like, oh my god.
Suitcases at an airport, it's like not a cool thing. People suck, right? Like, and you have to be careful. But yeah. Anyway, I don't mean to make this a morose thing. I just don't want. I don't want people to leave their drinks unattended because I know
That's
how.
a good message.
Yeah. You didn't think you were coming to the Iron Yard today to learn about whether or not someone would lace your beverages, but we talked about it anyway. All right, so it's 11:26. Let's get back to the lesson. So we're going to learn about interfaces. All right. So we'll start with an example. So let's go to array list. So we're going to build a new array list. It takes strings. We're going to add Alice, Charlie, and Bob to it, right? We need to project the screen to Apple TV. And also probably reshare on Google+. On Google+, I'm not touching my hair. Okay, so in our Groovy console, like before, let's go back to, where is it? Oh, okay. We're just gonna keep it in the forum for now.
Where are we on the lesson? Like on our.
So for today's current assignment, we're down near the interfaces section. Okay. So in Groovy, what we're going to do is say array list string names goes new array list. Right? We're going to do names.add Bob, names.add, Alice, Charlie, Bob. Okay, step one, do that. Let's run it. So we just have Alice, Charlie, and Bob in an array, and it ends, or an array list, and then it ends. Okay. So now what we're going to do is sort it alphabetically. Collections. We can do this by calling the sort method on the collections class. So collections has a static sort method that takes in a collection, like names, and returns a sorted version of that collection. What's up, Lucas? She has not been in here for a while now, actually. Yep. You should be. I would rerun this. Hopefully it shows up properly in our Groovy window. Well, let's print this out, see if it prints out properly. I always forget if ArrayList overrides toString appropriately. Man, this Groovy window is not all it's cracked up to be. Okay. Names equals stuff. Jesus. So we're trying to use this Groovy console in class, but in application, it's never really working out that great. So we're going to change our approach here and use the main method and what we're currently working on to test our code, okay? So I'm gonna comment all this stuff out, make it bigger. All right, and we're gonna try system out the front line names. We'll see if, yeah, okay. So we have Alice, Charlie, Bob, right? This is our output. They're unsorted. You can see Alice, and then there's Alice, and then there's Charlie, and there's Bob. But if we do collections.sort names, we see that sort returns a void type. So it does an in-place replacement of names. So it's going to, after this runs, we don't have to say named equals collections.sort names, which is when we do this, it modifies the contents of names. Okay. So afterwards, we're going to print names, and it's going to say Alice, Bob, Charlie instead of Alice, Charlie, Bob. So it's going to do a lexicographical comparison of each character in each string and order them. Okay, that's what sort does. So next thing we need to do is sort a different type of object. So we just sorted strings, worked marvelously. Let's try to sort something else. In this case, let's try to sort a person. So let's make a concept of a person first. Make this bigger so people can see it. And then the person's going to have a string name, right? They can, so only one field for now in person. Let's go ahead and generate our constructor based off of name. Let's go ahead and construct getters and setters based off of that name. Okay. Now what we want to do is make a list of new people. So instead of saying names or array list string, let's say array list people or person people, and then oh man, check this out. Use Shift F6 people. Bam. Yeah, if you want to do a rename, like you could just go here and delete this and say people instead, but then all the things that reference names would not update. If you want IntelliJ to smartly rename all things to this new variable name that you want to do, is Shift F6, this box pops up, you type people instead, and you hit enter, and it updates all things that you did reference to the new thing you want to reference. Yeah.
I'm glad I asked that question.
Oh yeah, you've been using that a lot? Yeah, nice. Okay, so instead of adding strings to this array list, we need to add people. And we know that the person class accepts a string, which is the name. We'll do Alice, new person, Charlie, new person, Bob. Okay, let's try to compile this. Crap, no problem. No suitable method found for sort. Oh God, what just happened? Why is it doing this all of a sudden? That's not cool, man. Did our Apple TV just crash? Oh, it's back now. Now I gotta reshare my Google Plus window. Okay, so we have a problem. It says no suitable method found for sort. Okay. So we have a problem here. Oh, look, we anticipated that. No suitable method found for sort. Crazy, right? So the problem here is that Java, by default, for your random class that you define, it doesn't know how to sort those things. It doesn't know how to compare those two things. So like for integers, it's easy to sort integers because 0 is less than 1, and 1 is less than 2, and 2 is less than 3. For strings, it's also easy. It's just lexicographical. It's based off of the character. So A is less than B, which is less than C, which is less than D. So A is going to show up first. So A through Z, right? For persons, it's like, I don't know what you're talking about. Okay? Error. As you can see, specifically, error. So the way that Java handles comparisons is by adding this comparable interface. So check it out. If we open up our person class, so remember how we had extends before? Okay. There's another keyword called implements. Okay. Sorry? It's not like importing a class. Yeah. So when we do implements comparable, this little window pops up. So class person must either be declared abstract or implement abstract method compare to incomparable. Okay. So the method compare to. If we take a look at this interface, comparable, compare to is a method that accepts a type object and then returns integer. Okay? So if we check out this code here, this is us implementing the method that the interface specified, right? So here we're defining the compare to method on person. So if we pass in any arbitrary object to our person, if we want to compare two person objects to one another, we're going to convert that object to a person, right? And then we're going to just compare them by name. So we're going to say that the order of objects, of people objects with respect to one another, is the same as the order that their names show up. So the Alice person should show up before anybody else, before Bob, before Charlie. So we're like, whatever the results were when you compare their string values, that's what we want to have for our person class. Okay? So if we rerun this, well, the toString method, it's like jacked up. So we've got to generate our toString based off our name and enter, rerun it. We can see that it sorted successfully. The first person was Alice, the second person's Bob, the third person's Charlie. So it's sorting the person objects the same order that it would sort those person objects' names. Right?
So you basically pass directions on
Yeah.
with your
I'm sorry?
with the override, correct?
Yeah.
So it freaked out because it didn't have instructions on how to sort
Yes.
persons.
Yes.
And then you were like, hey, check this out. This is how you do it.
Yeah. So what's going on here is that when you call this sort method right here, the sort is like, give me an object that is sortable. And then I'm going to just try and call that object sort method. Right? So in this case, all the sort method needs is to be able to compare two objects to one another. It's like, so it's going to arbitrarily, so what happens is that this comparable int is going to return either a negative number, a 0, or a positive number, right? A negative number means that this object is less than this number. Positive one means that this object is greater than this number, or this object. And a 0 means these are the same in order of priority, right?
Yeah.
So if I'm like, if I do my compare to logic and it turns out to be negative, I know that this guy comes before the second guy that I passed it.
Yeah.
So that's the sort method. All it needs is to be able to compare two objects to one another, and it'll handle the rest of the sorting. It's going to use that series of comparisons to do like a round robin style, like here's where we order our stuff, right?
Yeah.
So that's an example of an interface. We implemented an interface here in our person class to say that this is comparable. You can compare, this person is comparable to another person, and how it's comparable is it has this compare to method. The definition of this compare to method. So this is pretty powerful, and also probably hard to wrap your mind around the first time you see it, okay? So think of what the sort method has to do. It has to accept anything that is comparable, right?
That's a lot of work, right?
Well, it's not necessarily a lot of work. It's if we think about if there were a world with no interfaces, if we didn't have interfaces and we wanted to achieve this same goal, right? The only mechanism that we have to share functionality in the Java language, disregarding interfaces, is through extending classes. Okay? So if we have a class person, it can only extend in most one class, right? So by the way, I'm not sure if we explicitly specified, we've just been implicitly doing this. You can only extend one class. So like a rectangle can only be a shape. Its parent class can only be shape. It can't be shape and something else, right?
Which is why you would use this.
That's one of the reasons. So like, if we think back to our polymorphism example from earlier this week, and we look at the compare to method, compare to would have to accept any two objects that are comparable, right? So it would have to accept a comparable and return an int, right? And the current object would have to be a comparable. So in the world without interfaces, we would have to be extends comparable, right? So that would be saying every person is comparable, which kind of makes sense from an English perspective. But that whole analogy kind of falls apart. So like
in a CRM or something, you wouldn't want to compare every single person, right? So like you'd want to compare like levels. Like gold
I'm not
level,
sure.
silver level, like those kinds of things. So
Okay.
you only want to compare like within like groups.
I think so. I mean, I think you're on the right track. I can't quite wrap my head around what the CRM is doing there, but
Like in a retail store or something. Like you have a silver level customer, gold level customer, or like just a new client.
okay,
And you'd want to compare like your silver level to the silver level, or like the gold level to gold level.
sure. I think that's a great case for why you would use comparable, but I'm not sure if that's a good example of why comparable can't be a superclass of person.
Okay.
So like, if I have the class hierarchy, object, shape, rectangle, square, right? An object is at the top. And then later on, I want to make this sort method, right? That doesn't fit in that hierarchy anywhere, okay? So they added this new functionality called an interface that's like, okay, so keep your hierarchy of objects. Like that's all good. That's all the same. That makes sense to you. You modeled your data appropriately.
all squares are rectangles, all rectangles are shapes, all shapes are objects. Perfect, right? But we want to be able to extend its functionality. And so by implementing an interface, you're signing what's called a contract. So this is not a Java contract. This is not like a Java terminology. This is just general programming terminology as it relates to interfaces. It's like a contract for what your class is going to do. So if I say I implement comparable, you saw it complained to me until I implemented the compare to method, right? It was like, had that red squiggly line. Saying you implement an interface says that you implement a method that is defined in the interface. So if we look at the comparable interface, it's got a lot of stuff, right? I mean, and I would encourage you to read exactly all it has to say here. With an interface, it contains method signatures. So do you remember method signatures? They are how you define a method. Like, you have a return type, you have a name, and you have what it accepts, right? Interfaces are the same thing, except they don't have the implementation, right? So you see here, this defines, if we take this, and we want to build a new class, and it's going to be an interface instead of a class. We're going to call it flyable. We have public interface flyable. And what we're going to do is specify that any class that implements flyable has to have a void fly method. Anything that's interesting. Anything that is flyable has the fly method.
But you're saying instead of extends, you would implement fly.
Mm-hmm.
Okay.
So like, if I have an airplane, for instance, airplane might inherit from machine, which might inherit from object, right? Airplane is a type of machine that can fly. All right? So flyable, if it were a class, it wouldn't really fit in that architecture anywhere. Like a flyable class doesn't really say anything. It's like it doesn't fit between airplane, machine, and object. It's just doesn't quite work out like that. But you can say that take their hierarchy of object, machine to plane, and say plane is a class that you can fly. So in plane, we guarantee you that a plane can fly. Not machines can't fly, right? And objects can't fly, but airplane says it implements flyable, which means we know it defines the functionality for this method fly.
So just curious as to how you would recommend. So a plane can extend a machine.
Yeah.
And also implement flyable?
Yes.
Okay.
Yeah. And you can implement any number of interfaces.
Oh, okay, but you can only extend
You can only extend one class.
classes.
You extend classes, you implement interfaces.
Okay.
All right. So if I wanted to make an airplane, well, hold on. Let's say we want to like fly to the grocery store, right? Let's comment some of this stuff out right now. Oops. Gosh. So say we want to be like, we have this public static flyable get flyable object, and then we want to do int random int equals math dot random times 3 and cast it as a double or an int. Instead of a for loop. No, it's not a for loop. So if random int is equal to 0, return new bird. Else if random int is equal to 1, return new. What's the thing that can fly?
Airplane.
Okay, so I guess we'll do airplane. And then else if random int to, owl's not a good example because it is a bird.
Alright.
Return new dragon. I like my suggestion of dragon. That's super badass. All right. So we have this method. We've seen this before, right? This is a factory.
Mm-hmm. Factory. I like that.
It's pretty cool. So this factory is going to return us a flyable object. Okay, so anything that's flyable is valid a return type for, or is a return type for get flyable object. So say let's define these classes real quick. Okay, so we have a new class, bird. Birds, they don't inherit. We don't have any inheritance right now. We can make an owl later that can extend bird if we want to. So all we know is bird implements flyable. So all birds can fly, right? Superman. Okay, we need Superman. We have to update this. Else if random int is equal to 3, return new Superman. Okay. Which is pretty good because I can inherit. You can inherit from man or whatever, but he's not really a man. Whatever. Okay. So if we hover over this, we have a class bird must either be declared abstract or implement abstract method fly in flyable. Okay, so let's implement fly. So we have override. We have public void fly. Is a method that accepts no parameters, returns nothing, and we'll say, I'm a bird, right? I'm flying. Right? So airplane. So we'll do the same thing. We want all airplanes to be able to fly. Implements flyable. And then we have to do a public, we have an override flag. We have system.out.println. I'm an airplane flying. Okay. And then we have dragon. This. There we go. Then we have dragon implements flyable as well. Override, public void fly. Send out the front line. I'm a dragon. Burning and eating. Okay. The reference to Homestar Runner, which I've already established, you guys don't know about, which is it. All right, everybody knows Homestar Runner. In my dragon class, I said that he's a dragon, but he's burninating the countryside. Burninating all the villagers. Okay. All the people.
Doesn't seem as amused.
All right, brief aside, just real quick. No, we'll do that later. Okay. All right, so we have main. Let's get rid of. Again, I need to get rid of all these other things because it's a lot of things open simultaneously. So we have implemented bird, airplane, dragon. Now we're gonna do Superman. So we have Superman. Superman. It's a class. Superman can fly, so we're gonna implement flyable. And then we have to create an override for that. And so system.out.println. It's a bird. It's a plane. No, it's a random guy in a cape that looks just like Clark Kent. And he's super strong. It must not be Clark Kent though. Right? Okay.
So we know your feelings on Superman.
Well, it's just, I mean, it's like
It's pretty
In reality, the
Right.
difference between Clark Kent and Superman is like the glasses he wears. Not. There's actually a funny SNL skit about that. Okay, so get flyable object is going to give me one of these things randomly, right? We know that much now. So what I want to do in main is get a random flyable object and then fly. So we're going to get flyable object.fly. And we know we can fly because we know that whatever object passed to us from get flyable object implements an interface. We know since it implements an interface that the interface we defined is fly. So we're going to call that. So let's do this like 5 times. Okay. Ruh-roh. Oh, because I changed this to extends, for example. Oops. Oops. So let's hold on. Let me make sure I'm still screen sharing because I think I just maybe minimized something. No, I definitely am. What? All right. I forgot to return this up. Oh wait. Let's just change this to an else so that this error message goes away. So it's complaining. It says if that number doesn't happen to be one of those things, you're gonna not return anything. So we can see here that our factory did a good job returning random objects. The first case it was a dragon. Second case it's a bird, and then a dragon again, and then another. Oh, it's Superman. It's a random guy, and it looks just like Clark Kent. He's super strong. Must be not Clark Kent, no. And then the other one's a bird, right? So the functionality was defined by the class that implemented the interface, right? The interface just guarantees that you wrote a method in your class that does that job, right? It doesn't. The interface doesn't give a crap what you did. It's designed specifically not to give a crap what you did. It's like, I don't care what you do, as long as you return this and you accept this, and the method is this, do your own thing.
So can you define which one you want?
To find which,
Like, can you say, I want, like, can you do that so it's not random, so that you're picking out, like, Superman?
yeah. Well, I mean, if you wanted to just return Superman, then you could just return Superman.
Okay.
Right? We could just say, we could reassign random int to like billion, right? And then it's always Superman's.
Oh, okay. Okay. But why would you wouldn't do that?
I mean, you would. I mean, you wouldn't build a factory that returns a random object.
Yeah,
Right.
yeah. Okay.
I mean,
It'd be dumb.
well, in very specific edge cases, would that be useful? Usually, you pass in a string that represents like the criteria for that object. So, like for characters, right? We pass in a good guy,
Right.
and what we return is a person because that persons are good guys. But enemies are bad guys. So if we added to our factory, if we specified bad guy, then it gives us an enemy object. Right?
Yeah.
In this case, I just wanted to illustrate the differences between these classes and how calling the same fly method it had different effects based off of the object that it gave me.
So the
Gotcha.
purpose of this would be that you could have a fly method in all those classes without them being, like you could just implement flyable into all of them and they would automatically have fly classes.
Yeah.
That would be the use.
So check it out. If I made a method called like fly to the grocery store, right, and it accepts a flyable object, okay, then I could use any object I wanted to fly to the grocery store as long as I could fly. Right? I could use an airplane to fly to the grocery store. I could use a bird to fly to the grocery store. This is obviously a contrived example, but you get my drift, right? Like you could use any flyable object to fly to the grocery store, which is pretty cool. Especially if you add later on new things that can fly.
Right.
Because if you add a new class later on that can fly, if you just say it's flyable, then you can run that method on that object. and then it's done.
Yeah, because we have to make a whole new thing in that class, right?
Yeah, exactly. If you write your code to an interface, then you're not relying on the implementation details of the class. You're like, this is just an interface. I know I'm going to get this type of object. It's up to the class to give me that, right? So you can then swap that class in and out of the interface, and the functionality should still be the same, right? Because you don't care what the class does. You just know it gives you certain things. So this is actually super relevant if you're talking about like database systems. Right? We haven't talked about databases yet, but you guys get the drift of databases. They store data, right? And in order to store data, you have to like have a library in your respective language to be like write data to the database, okay? And the details of those databases are all different, like how it succeeds in writing the data to the database. But if you had like, and oftentimes when you do database transactions, it's often referred to as CRUD operations. So CRUD is create, read, update, delete, right? That's usually, like if you have a CRUD app, it does a very simple thing. It creates objects, it reads objects, it updates objects, it deletes objects, right? So imagine that you had an interface that had 4 methods: create, read, update, delete. And you used database library A, right? So as long as database library A implements that interface, you know that it can create, read, like if you're using MySQL, for instance, as long as it implements that interface, you can use it. You can use methods that use that interface with reckless abandon. You're safe from implementation. So later on, if you're like, oh shit, MySQL's not cutting the cake here. Is that a thing? Cutting the cake? It's not cutting the mustard.
It is now.
Okay. So MySQL's not cutting the cake. All right. It's someone's birthday, and we got to cut that cake, right? MySQL's not doing it. We want to move from MySQL to Postgres, right? This is another database library. If in our code, we had written all of our code to use MySQL stuff that was specific to the MySQL library, then we'd have to go in and we had to replace all cases of the interaction with the MySQL library with the Postgres library, which introduces lots of issues and bugs and concerns, and it's not great. However, if we were disciplined enough to just use an interface instead of directly using the MySQL libraries, then we could swap the implementation of MySQL with Postgres. And as long as Postgres also implements that interface, you don't have to modify any other code. This is a term called dependency injection. We'll get into it later. But it's one of the biggest, coolest things about interfaces. Yes, it's a great architectural tool. And I think that the more we deal in code, the more you'll see the value in interfaces. So it might not be totally obvious right now, like why interfaces save your ass, but they do a good job of doing that. I know that this is a new concept. We seem to be learning a new concept every day while we're trying to absorb old concepts, and it's a lot. It's a whirlwind of information. As we practice, as we keep going, these things will be solidified. We're baking a cake right now. We got to put it in the oven, let it bake, right?
So I'm planning
I'm a
on
fan of
spending all
analogies.
weekend like reviewing and like doing this. Like I want to.
That's good.
Yeah.
I mean, that's what we expect. Have healthy boundaries between the iron yard and your life, right? But it is a priority. So,
Right.
okay. What does it say? 13. Okay. So I have a meeting here at 12 o'clock. So sadly, I need to. I mean, we're done talking about interfaces, so we should just break for lunch. Well, let's be back. It's after 12 right now, so let's just say be back sometime around 1, like maybe 1:15 is fine. After that, we're going to talk about what the assignment is for the weekend homework, and then we'll let you do your thing. Okay? Work on.
Go home for lunch
Okie dokie.
because I didn't have bread and peanut butter to make my sandwich this morning. I had like chicken that was thawing in the fridge, and I was like, I can't do anything with that.
Wait, hold on. Hold on. Before you go home. Because I don't know what's happening right now. And there is a possibility that food is being brought in.
Oh, yay.
For real?
I'm not saying it's a for sure
Oh,
thing.
I know.
I'm all down for free food.
Me too.
I don't know. I'm just, I need, let
Who are
me
you
read.
talking to?
I'm reading messages that have been sent to me for the past like hour and a half. So, just let me go regroup with some of my colleagues here at the Iron Yard and let you guys know who's happening.
Good.
And what are you eating?
Don't be sad, don't be sad.
No, it's Thursday. Why are you laughing so hard?
Because that was hilarious.
Please.
Oh, it's funny.
It's Thursday.
Oh, yeah. Yeah, if you wanna, keep that website.
What is this?
It's just this, oh, it's like from University of their course, or I don't know what it is.
So it's like go to Kevin for the.
You can open on like,
Did you post it on Slack?
Lisa,
Yay, pizza.
Oh,
pizza?
You don't eat pizza?
I mean, no.
You don't need
I love
to worry.
pizza. I'm just.
What's that?
I'm with you.
What you got there? They're in
I
the room.
can't eat pizza without blowing
Are
up,
those the last?
but I'm gonna eat it because it's.
I don't really
It's
care about
like-
blowing
It's an
up.
energy drink.
It's not
Yeah,
side.
that's like.
Like what?
healthy.
I care about blowing
It
up.
literally says healthy energy.
It looks like weird.
So I guess it has like
Do you blow up?
antioxidants and vitamin C.
That's probably why I don't care. Like, I care.
I don't really care about my weight. I'm just conscious about, I mean, I care about it, but I know I'm not gonna eat the way and the way that lactose is gonna make me like this.
Yeah.
So I don't really care.
I have like 2 pieces of pizza though, and I'm huge. Just watch, I'll eat 3.
You're talking about you blow.
Yeah, but like for days, for like 10 days.
What?
Yeah, it's ridiculous.
Is it bread?
Hmm?
What is it about the pizza?
I mix bread. This was gluten.
So then
And same with like my body's so sensitive, like when I walk outside if it's too hot, like or if I go running, my hands will swell to the point where I won't be able to grip.
what?
Yep. It's weird.
Yeah, I like order kind of small Domino's pizza and just eat the whole thing right there.
I love pizza. I used to be really skinny when I was like in college. And I weighed like 105 pounds, and I would eat like large pizzas by myself, and I would be able to I wouldn't gain pounds. It was insane.
Yep.
And I was like, oh, this is awesome. It's so tiny. No way, girlfriend. But then like later, I'm like, I'm getting anything.
It's really weird.
It's weird. Not
I
like
think 1.5 cups of coffee. Yeah,
What is this?
it does taste weird.
It tastes good.
What is it?
The mod tea
So I
that she
guess,
brought in, that Dana brought in from Raleigh.
Ooh, is it healthy?
So this girl started brewing this in her, to like battle her depression. Were you there when she was telling us this? Yeah, so this girl who went to, school in Raleigh, must have been upstate or somewhere. So, she was really depressed because she just had like a really overwhelming like workload. So she started brewing this.
Sounds like.
And people started asking her about it, and like they would try it, and she went through like thousands of different batches and like brews until she made this, and now she sells it.
That's awesome.
Yeah, and it's really good.
I'm going to get one. We're all in it for.
Yeah, she finished her glasses. Good question.
Good to know that, right? That's pretty cool.
Actually, I don't know. I just.
She's like, nope. Maybe she's like, well, got all this money now. Billionaire.
Bailed out.
She was like, I've made the perfect mochi batch.
Cool.
I think she's ordering.
She just ordered it, I think. Yeah, I'm hungry, so I'm gonna eat
Share
that.
them. I mean, I hope so, right?
Yeah, we asked.
You asked for permission?
We did.
Do I need to ask for permission?
No.
Because they're here to share.
Yes.
Yeah.
We asked if that was okay.
Ooh, since you're sitting there, just waiting for me to ask you a question, Will.
God, I think you probably do that.
You look like you're hot.
You know, we're going to talk here or next door?
Probably here.
Here?
I mean, unless Lynn says I'm out, but probably here.
I'll go grab them.
Um,
You guys looked downstairs recently?
They,
No, not.
you're talking about our space?
They have, all the, the 25th is, we're moving in from Colorado High Water.
Yay!
Oh, wow, yeah, so we got, we're bringing all this stuff up. Fantastic. Things going well? Yeah. Good. How's Suzanne?
Good.
Suzanne's Conrad. Yeah, Suzanne's great. Have you guys met Dana yet?
Yeah.
Okay. Yeah, two of our best campus directors. Two people who care more about you. And Dana. You focus on your stuff. The other stuff. I'll go grab the rest of the folks. And bring them.
I need your help.
I can help.
Well, in two ways. I got a lot of errors here. I just start writing something. And I got a lot of errors and I don't know why they're there. And the other thing is that I'm going to show you. So here you go. Just take a look, see, and you can tell me what to do because I learned better that way. That'd be really
How much that, I mean, to do.
See it, you know?
You do it for me, you're like, here, let me get in here.
Or maybe.
I was trying to explain.
You want me to put it on Apple TV? Would that be helpful? More helpful?
No. Okay, well, let's do this.
You're
Let's
about to show me yours.
explain.
I don't want that.
Well, I'm not gonna do that. I won't show you, but I have to at least look on mine. I'm not bent. I'm not like, I can't just look at your phone.
Oh my God, you know what I wish that that popcorn was?
She asked me to help her.
Hey, I'll take both of your help,
I
all
wanna be-
right? My, I'm gonna reserve you
I
for
wanna
later.
feel-
No,
I
I'm
wanna
gonna
feel
hold
like the
you
expert.
for later.
I wanna feel like the expert. Hold on a second.
Both of you do, you fight for it.
I love it. I'll take it. I need it. I need your help.
So,
I know that that is not.
all right, so I already know you have a C problem where you practice.
Why?
Why?
Because if there are no, it doesn't.
Because this, that should not be,
But I'm saying, I don't understand why it's something I'm like this.
what I'm trying to say is,
Somebody remember me. Did you?
Yeah.
How'd you make them?
I put this.
Wait, focus. Sorry, later.
Yeah.
you know what, you're gonna have to sit there because
I'll do my best. So, this is my main class. I'm attempting to syntactical. It's like popcorn.
That's just real.
Yeah, that's actually.
So, I believe, I think I did this where right, maybe, yes, yes, for each inventory item, yes.
Why then stairs?
Are they?
Well, they're also. Good question. Because I thought that they were supposed to be made, now I'm thinking, why are they not made?
Did y'all have any class this morning?
Yeah.
Awesome.
But I thought that would be
Pizza coming in. Cheese and pepperoni. So it's probably lasted like 30 minutes, but just gonna get started talking. So I thought I could hear. I tried to get there right here.
Or you're maybe watch my Netflix, I can't remember I think I can. Which email it is. I think it's under Lindsay right now. I have 4 email addresses. Really?
It's gonna basically extend. So you're.
How are you?
Hi.
Hi.
Yeah, we're doing
Good morning.
presentations right now.
Good class?
Do you need the projection?
Yes. Yes. I know. JavaScript land over here. I feel you. I'm telling you, it's gonna come along. It's gonna come along.